Okay, in this video, I will go through the Lab 8.2, which we have done in semester 1, the last lab. Unfortunately, I cannot finish marking, and so I will need you to exercise your self-discipline to self-mark, and then after that, submit to Mr. Goh for checking on your corrections. Okay, so what I have done is that I have randomly took 3 sample script, and then we will look through each of them and see what are the common mistakes, and hopefully you will learn from it. So there are 3 videos, each video covering 1 question. All right. What happened is that we need some expectation, right? So like I said, the standard expectation is that you shouldn't make mistakes like how many DP for readings. That shouldn't happen at this stage. You shouldn't make mistakes on either using list SF or list DP for calculation, and you shouldn't make any more formatting errors in your graph or your table. So that is the basic expectation that you should have for every lab from this point on. Okay, so let's take a look. So for question 1, I think it is a design question. Design question, like I said, the first few steps given by the question will give you a good sensing on what the design is about. The problem is that students is unable to understand what do you mean by a good sensing. So what happened is that the dummy way that I always advocate is you look at question 1. Question 1 have a design question right at the end here. K. So meaning that the steps are from A to J will be the hints to you for your design. So what I will do is that before I even start the lab, I will take a look. Okay, step D, I am finding L, right? I'm finding L. So I will, in my mind, or I will write down on a rough piece of paper or somewhere on the question script, I will try to form, okay, I am getting L. Then after that, I am getting small l, right? Why do I do this? Because I know that these are the measurement, the readings that I'm getting. So I know that these are candidates for your dependent, independent variable, right? Then after that, the question then lead me to do some calculation. So I will use a different color pen in my exam. I will use different color pen to remind myself that what are calculated value, what are measurements. So I got x. Then after that, it tells me to find this square root x. Then I have square root cm. Then after that, I would have to have an average time t, right? Which is here. So I know that in question 1, the first few steps, step A to J, I will be getting things like this, right? And then basically what I have done, if I follow the step A to J, I would, A to J is here. I would have some reading here. So this is my first set of reading, which will enable me to plot a certain graph, don't know what versus don't know what, and I will get 1 data point. And basically, I just need to repeat this entire process so that I get more points, right? I will get something here, I will get this, I will get something here, I will get this, then eventually I will get a relationship, right? And in this relationship, somehow the gradient of this will be equated to certain thing, and I have to find something from here. So this is what I mean by the first few steps in your question 1 will give you a sensing on your design question, right? Okay, so now let's zoom in and see how our friends do in this particular design question. Okay, let's see. So first thing, you are supposed to measure L, which you have a certain range. Wait, let me pick a pen. This range, let me see. Okay, so I have a range 49 to 50. So anything that falls within 48.5 to about 50.4 will be in range, right? So I take a look, 49.5, 1 dp, correct, so correct. 50.0, unit is correct. So all these correct. Unfortunately, this one is appetizer, so you can see that there's no mark. Okay, you should get it correct. Okay, then after that, then you are supposed to adjust the bottom and record this small l between this value, right? So, okay, is in range, correct. So you get 1 mark for this. Then you get this, correct. 1 mark for this. And then you have this, and you get 1 mark for this. Alright. Then after that, you are supposed to do calculation, and since none of these are none of these are averaging, most likely you will do least SF, except you can see that you are doing simple summation or simple subtraction. So this one should be least DP, and I think this particular student got it right. The unit also correct. So 1 DP, unit correct. This one is correct. Square root, you will follow least SF. Right? So this one is 10.6 is 3SF, and so this one is 3SF as well. So you will get this correct. Unfortunately, you can see that this student slightly weaker in math. So if you square root x and x as a unit of cm, then cm will appear as square root cm as well. So because of one mistake, this one 0. Okay, it's either 1 or 0, there's no half mark. Okay, let's take a look at this one. Good, that's working. Good substitution. Least DP. Very good. Then this one, least SF. This one, why no substitution? Okay, so this one is square root 11.3. So therefore, I should have 3SF because I come from a 3SF figure. So very good. 1 DP, unit correct. 3SF, no unit. Okay, so no unit again. bỏ liao, right? One mistake gone. Third student, no working, but I know he did the correct one. Okay, then square root this one, 3SF, very good. He write down this. Good. Can, okay, is either square root cm, or you can write cm to the power of minus 0.5. Very good. Right, so just look at this. You are seeing that this question is able to distinguish students who are more confident about their math, or who are more diligent in following through the rules, applying the rules to the unit as well. Okay, then after that, this case, like I said, nowadays, if you see accurate thing, I must see your effort in doing averaging. And when you do averaging, you will follow least DP rule. Okay, so this one is 1 DP, this one is 1 DP. The 2 here is no count because 2 is just number of readings. So unfortunately, wrong. Okay, this one, the least DP should be 1 DP. The answer should be given as 10.4, which she did in the answer. So it's fine, right? We will mark her correct. Unit is second, so she will get 2 marks. 1 mark for showing the averaging working, 1 mark for showing the value. Okay, so first trial, okay, you want to do it this way also can. Wait a minute. Okay, correct. Okay, so 1, 2, 3. Okay, this one, wrong. Averaging is to follow least DP. Okay, it should be following the least DP rule. So unfortunately, this one, wrong. Okay, so I will give maximum of 1 mark. So some of you may ask, what if teacher, I show the working right, I go and write 2SF, but somehow, let's say my answer I give you, let's say for the particular student, let's say in the end, I write the answer as 10.5. But my working, I go and write something like this. I go and write 3SF. Will you mark me wrong? In this case, O-level, I will just mark this correct, and I will circle this. I will put wrong, but I will still give you full mark. Okay, that means I will give you the benefit of the doubt. maybe the student mean it is 1 dp, okay? Just that he write the 3SF as a mistake, okay? I will still give the full mark. I will condone it, okay? So don't worry, having more working will not penalize you. Some students feel that the more I write, the more you penalize me. No, 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 it's not like that. Positive marking, okay? We'll mark what is correct and we'll condone as long as you don't contradict. Okay, third student, even better presentation. Okay, first reading, unfortunately, basic error. Okay, for your stopwatch, okay, please memorize it properly. It is 1 dp. So this one wrong, and as a result here wrong. This one is also wrong. So unfortunately, this is wrong. I can only give you 1 mark for averaging. Okay, so this one, this dp rule correct lah. So this one, yeah, it should be this dp. Okay. Okay, now let's look at your design. So I can see that for her, she follow my teaching very good to make sense of the thing. Let's look at how she processed this. This is the given formula, and you can see her second step. Like I said, just by looking at the first, I know this student a bit weak in math because second line already make mathematic error, right? I think the student is trying to remove this. So how do you remove this 0.5? Well, you cannot just erase this. You have to remove it by square both sides. So if you square both sides, the 2 you bring in, right? The 2 will bring in to all the component, right? Sorry, the 2 you will bring in to x, you will bring into pi. So yeah, x square root whole thing square, you will get x, but the pi here will be pi square. Same thing here, the t here also wrong. So actually down here, the correct equation should be t square g equals to pi square x. Yeah, then after that, I think the student trying to make t as the subject. So if you continue on with this, you will have t square equals to pi square over g. This whole thing is a constant, and then after that x. So eventually, I think this student will get penalized quite badly because of this one error, because you are supposed to plot t square versus x, not t versus x. So here, let's take a look. So to mark this, right, usually I will look at the graph first. So if I look at the graph, you can see that this part here, this part here is already wrong lah. Okay, it should be t square versus x, and it comes from her math mistake. So down here for this particular one, already got 0. Okay, then let's look at her classmate one. Classmate here didn't provide much calculation, so let's take a look at her last step. She is plotting t versus x square root. So most likely for her approach is simple. Just group everything to the other side. So for her, she turned this into t square root g equals to pi square root x. I didn't change anything. So for her, she just make t the subject. Then down here will be pi over square root g, then square root x. So this is her y-axis, this is her x-axis. So it is accepted as well. So for this particular lady, this statement is correct. Okay, so she will score the 1 mark for this. Okay, already 1 mark. Okay, then let's look at the third student. Good, he provided. Okay, this one is correct mathematics. So he did the correct mathematics, right? T square versus x. So this will be his y. This will be his x-axis. So let's take a look here. I can see that this is correct. So that's why I say the first step is always to play with the equation, right? So here, statement for graph, correct, 1 mark already, right? Next thing, I will then check whether he has the correct independent and dependent variable. So since you are plotting t and x, unfortunately for your x, right, it is a process value that comes from big L and small l. Alright, so let's go by, I think let's start from the first student, right? You can see here, your x actually come from big L and small l. Right, and let's take a look here. I think the big L is fixed. Yeah, big L is fixed, and basically you are moving this rod up and down to get different small l. So big L is fixed, small l is adjusted. The time is the dependent. So let's see. The independent variable, very clearly written, is the length of the string to the bottom clamp. Okay, small l, correct description. Dependent variable is the accurate time taken for 10 touches. Very good practice, right? For 10 touches, I feel that the letter here is not big T. I think it is small t, right? Or T for 10 touches. Oh, time taken T for 10 touches. Okay, so yeah, okay, so it is big T. Okay, usually it is given as small t. Right, so this one is correct. So I will give 1 mark for this already. Let's look at her friends. Length x. Unfortunately, this one wrong. Your this thing. Okay, your x over here, okay, is wrong, right? X is calculated. So unfortunately, this one wrong now. Yeah, it should be small l. Time taken, correct. Didn't tell me it is in seconds, right? But because the first error is quite glaring, so unfortunately, this one, 0 mark. Okay, then let's take a look at here. Very good. Small l in cm, correct description. Time taken, correct simple description. So 1 mark also. Right. Then after that, since we now agak-agak know the thing, the next easiest things to mark will be your table. So let's go to the table. So for this student, need capital T square. Okay, let's go down. Okay. So very good, independent first, followed by the x which he needs, correct unit and all that, and then finally the dependent variable. So the table is correct. So table is correct, this 1 mark can give already. Then down here, let's look at the table. He is plotting capital T and square root x. Okay, let's go down. Okay, this will be the control, is fine. The independent, calculated. Should need this. Unit missing. Capital T. So this one, depending on the benchmarking, we may condone this error and still give her the 1 mark, but sometimes can be 0. Okay, so for this, I hope she learned from this exercise how to determine the unit. So here, it really depends. Can be 1 or it can be 0 if the benchmarking decided to be strict. Yeah. Then finally, for her, she will have a lot of problem. So, okay, correct. And not a good thing. Okay, because this is the dependent variable. Dependent variable should appear at the last, whereas the independent variable should appear here. Whether they will deduct mark subjected to how strict it is. So same thing, this one should be square root cm. So agak-agak, this case, This case really depends. It's either 1 or 0. Right? So the next thing to mark, we will look at how the g in the constant is taken. So following from her, for practical, no error carry forward. So for her, if you look at her mathematics, you can see that for her, basically the gradient of this particular graph will be given by pi square over g, meaning that the constant g is given by this expression pi square divided by gradient. So let's see if she have this pi square divided by gradient. Pi square divided by gradient. So you see the one mathematic error cause this to be wrong. It should be g equals to pi square over gradient. So for her, remember to check the math. So unfortunately, this one she is getting 0. Okay. Let's look at her. For her, her gradient looks like this. Right? So her gradient will be gradient equals to pi over square root g, meaning square root g is pi over gradient, right? And if I make g the subject, it means it will be pi square divided by gradient square. Let's see. Okay. Wow. So this one clearly do not understand the math. Why do I say clearly do not understand the math? How can the x-axis appear here? So I know she don't understand the whole process, right? She is just trying to look at the equation here and make g the subject. So once I see this, I know she has not been listening or revising her work. So like I said, what you have done is that you play around with the equation to find out that, oh, actually, the suspected theory of this formula will give you an expression of this form, right? So what you try to do is that you want to verify that this equation can describe reality. So you decided to run an experiment, okay, and in your experiment, you collected some data in these two pairs, right? When your small l is something, you get some data here, right? And when you get some data here, you plot it on your graph, correct? You get a point. Then after that, you change the small l, you get some data, and this data become a point. And you keep doing this until you have 5 points. And basically, you realize that these few points will give you a best fit line like that. So just looking at the preliminary, you will see that, because these few points are this cross, this cross, this cross, this cross, this cross, are data that you get from reality, right? These are real data. And now the real data suggests to you following this trend. And this trend fits this equation. So you can conclude now that, oh, my theory that I discover or come up with, derive, fits the reality, and I can use this mathematics to predict a data set that is even further down. Then what happened is that now you realize that by plotting this best fit line, you can actually get its gradient, right? And the gradient here that you calculated basically coincide with this chunk of expression. So when you want to derive a constant from your data set, you should always rely on the gradient, because the gradient is the trend. It has the least random error. So because of that, that is how you come up with an expression like that. Gradient equals to that. So what you need to do is you need to express g in terms of the gradient. This is what you are expected to understand. And when I see that this particular student, give me something like this, I can see that she don't understand and she didn't ask. Please, this is already SEM 2. If you don't understand, go and ask. Okay? Okay, you should derive G from the experimental data in the graph. Okay, so I'm quite disappointed with her. Let's take a look at the disappointed in her not because she don't understand, disappointed in her because she didn't ask or revise or clarify her doubt. Okay, let's look at the third student. So for him, I can see that, wow, he bring up my spirit gradient, he equate to this chunk, which is correct, right? So therefore, G given by this, I can already give him the mark. No need to scroll down because he's just going to copy this. So very good. Just by doing these 4 things, you score 4 out of 6, which is good enough, I feel. Yeah, and of course, you can aim for perfection. So now let's look at the perfection. I look at the nitty-gritty, right? So let's go back to the first girl. Okay, the setup step. Repeat certain step to ensure L remain constant. Okay, since the question didn't demand the list of constant, you skip it, is fine. I will not penalize you. Repeat certain step to get the value of L. Unfortunately, this one can. This one not allowed. Okay, I want the measure and record step for your L. Missing. So actually I mark until here, no need to mark already because she would have lost this mark already. Cannot give, got 1 error, right? During benchmarking maybe it says 2nd error, but I think this quite a big error lah. Okay, then talk so much. Actually all these no need you want just say calculate what, just tell me what you want to calculate. Okay, and again the same mistake, never learn. This one actually no mark, you just tell me what you want to repeat. For 2 reading of the time taken, calculate the average. Okay, so this is the step whereby you can get the precaution step lah. So you get 3 out of 6, which is 50%, not bad for a practice. Let's continue reading. Now repeat step using different value, very wrong already lah. Yeah, confirm 0 for the details lah. Where is the measure and record step for your dependent variable T? Missing mah, right? Then you should have the tabulation step here. You tabulate, then you repeat mah. If not, you repeat, then you tabulate, only got 1 reading in your table, right? So your tabulation step should be in front. Okay, then after that you repeat with different value for 5 other reading, can. Then repeat. Yep, so that's all for the design. Let's look at second student. Set up step. Actually all these are I blah 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 in my mind, no use. Okay, I see the measure and record. Record what? Length what? Small L or big L? Right, in cm or meter. So unfortunately this one is tick and cross. Repeat certain step. Record, not record, X cannot be recorded, X is calculated, right? X is big L minus small l. Repeat, measure and record time taken using what? Incomplete statement. Okay, even she mentioned here, right, it serves no use. Okay, I want 1 statement. Repeat step 4 and 5 3 times, calculate averaging. Okay, give it to you for the precaution. Okay. Then calculate x, tabulate varying L, repeat this step for different value. So for how many time? Never say. Repeat this how many time? Right? Don't have. Then plot. Okay, this one 1 mark. This one 0 lor. No choice Wow, a bit laggy Okay. This one how many? 1, 2, 3, 50%. Let's look at the third. Okay, very good This one write down the control. All correct the control. This one no need. Okay lah, you want also can give you. Okay, set up, repeat the step. Okay, measure and record small l using meter rule. Okay, very good. Calculate x with the expression. Repeat the action step. Measure and record big T, what you need, equipment. Very good. Calculate average T. This is the precaution. So precaution can. Very good. Tabulate. Very good. Unfortunately, incomplete because you need this So this one incomplete Okay. Then by varying this 5 other reading of T. Okay, for me, for that one mistake down there, I would highly give a 1 but if benchmarking is strict, they may give 0. So good job for the planning. So I will pause here. You can go and take a break. Then there will be another 2 more videos for Q2 and Q3.